Review for exam 3. In number 1, we want to find the point on the graph y equals square root x plus 2 that's closest to 0.60. Let's draw a little picture. Here we have an x-intercept at -2, x equal -2. Alright, so here's a rough sketch of y equals square root x plus 2. Let's put in 60. So let's see, here's 0. Alright, so there's 60 on the x-axis. And we're looking for the point on this graph that's closest to 60. So it doesn't look like it would be directly above. It looks like it would be a little bit off to the left. Let's mark this point. Let's name it xy. And let's call this distance, this minimal distance, let's call it r. So what we want to do is we want to minimize this distance r. And let's use the distance formula for an expression for r. So r is equal to x minus 6 squared plus y minus 0 squared. Now we want to minimize this. So we'll do that by taking the derivative and setting it equal to 0. But before we do that, we have two variables on the right, and we want to eliminate one of them. So in general, that's what's done in these problems. If you have an expression that you want to minimize or maximize, and the expression contains, on the right side, contains two variables, eliminate one of them, if possible. All right, so we're going to eliminate y using this expression. So here's an expression for y in terms of x. So we'll just substitute square root x plus 2 right here. All right, let's just simplify this. I'm going to multiply out x minus 6 squared. And square root x plus 2 squared, well, that's just x plus 2. So finally, we have, under the square root, we have x squared minus 11x plus 38. All right, now we're ready to take the derivative of r with respect to x, the remaining variable. And then we'll set that equal to 0. So dr dx is equal to 1 over 2 times the square root of x squared minus 11x plus 38. And we're going to do the chain rule now. Let's multiply by the derivative of the inside, and that would be 2x minus 11. Let's just remember that if y is equal to square root x, the derivative is equal to 1 over 2 square root x. And we can easily see that just using the power rule. Write this as x to the 1/2, and we get this. All right, so what we want to do is set this equal to 0 and solve. Well, here we have a quotient, and this quotient is equal to 0 when the numerator is 0, assuming this is reduced, which it is. So we'll just set 2x minus 11 equal to 0. And we have x is equal to 11 over 2. And that's the x value that minimizes the distance, 11 over 2. Okay, which is equal to 11 over 2 is equal to 5.5. And we see we were expecting our x value to be a little bit to the left of 6, to be up here, corresponding to this point here. So that's what we seem to have, a value to the left of 6, like we expected. Number 2 says, an open box is made from a square piece of material, 8 inches on one side and 8 inches on the other. By cutting squares from each corner and turning up the sides, find the volume of the largest box that can be made in this manner. All right, so here's the picture. We have a square, 8 by 8. And we're cutting corners out, square corners. And let's draw these dotted lines. So basically a box is going to be made by cutting out these square corners and folding along the dotted lines. Let's call X the side of the square. And what we want to do is we want to maximize the volume. So let's write down an expression for the volume. Remember, this each side here is 8. So this side is 8 minus 2x. And this side also is 8 minus 2x. So the volume of this box is going to be 8 minus 2x times 8 minus 2x times the height. The height is x. When the box is folded up, x is going to be the height. All right, so multiplying the 3 dimensions to get the volume, we have x, 8 minus 2x, 8 minus 2x. From the first factor, we can pull out a 2, and from the second factor, we can pull out a 2. All right, so we're pulling out a 4. And divide this expression by 2 once, and we have 4 minus x. And once again, 4 minus x. All right, let's get ready to take the derivative. So let's multiply these two factors together. So here we have 16 minus 8x plus x squared. I multiply through by x, and just to make it a little easier to take the derivative so that we can use the power rule, all right, rather than the product rule. So we have 16x minus 8x squared plus x cubed. Now we're ready to take the derivative. So that would be 16 minus 16x plus 3x squared. Let me just write this from highest degree down to lowest degree. And we want to know, when is this equal to 0? All right, because we want to maximize, so we're assuming the maximum occurs at a place where the derivative is 0. All right, so let's see if this factors. Okay, here we'll put 3xx. And here if we put a minus 4 and a minus 4, we'll get that positive 16. And what about that middle term? Well, here we have minus 12x and another minus 4x. That gives us the minus 16x. All right, let's set our factors equal to 0 and solve. So here we have x equal 4, and here we get x is equal to 4/3. Notice that if x is equal to 4, these little squares would be too big, and basically we'd be cutting out all the volume. There'd be nothing left. All right, so that seems to minimize the volume, not maximize it. All right, so we're going to assume that this one is the maximum. X is equal to 4 over 3. Number 3 says the sum of 4 times a first number and 3 times a second is 12. Maximize the product of the two numbers. So let's say x and y are our numbers. So we have 4x plus 3y is equal to 12. And we want to maximize the product. Okay, so we want to maximize this p, and we have two variables on the right, so we're going to eliminate one of them using this expression. All right, let's say we solve for y, say. So we have 3y is equal to 12 minus 4x, and just divide by 3. And we have y is equal to 4 minus 4/3 x. And we're going to put that in right here. So we have p is equal to x times 4 minus 4/3 x. Let's multiply that out because we're going to get ready to differentiate. So we have 4x minus 4/3 x squared. All right, now we're ready to take the derivative and set it equal to 0. dp dx is equal to 4 minus 8/3 x. And we want to find a maximum, so we'll set that to 0 and solve. Okay, so we have 4 is equal to 8/3 x. So x is equal to 4 times 3/8, which is 3/2. All right, so we have x is equal to 3/2. And to find y, we simply substitute into this expression here. And we have y is equal to 4 minus 4/3 times 3/2. And that simplifies to y is equal to 2.